So hello everyone. So this is Kartik Sapra back with another episode for Open Source Org Awareness Podcast, and we have Ashutosh Pandey with
Yeah.
us. So
Hi guys, I'm Ashutosh. I did GSoC 2020 with Arduino. I was an LFX mentee and currently I'm working at AMD as a compiler engineer. Yeah.
guys, Ashutosh will be telling about Arduino. So this is an open source organization as well. So he will be telling everything about Arduino to you, right? So how to approach Arduino as a beginner, where you can contribute to, and what are the communication channels there. So you people doesn't get overwhelmed with this hardware sort of thing, right? So this podcast will be about the hardware perspective of open source. So I hope you all will enjoy it.
So Arduino is basically a microcontroller. So to put it in simple words, it's a simple board that can be programmed to run one program at a time in a loop, and it can control things such as LEDs, sensors, servos, etc. So Arduino is one of the biggest examples of the world of something known as copyleft hardware. So you might, if you all are familiar with open source licenses, so there are open source is not open source until it is distributed under an open source license such as MIT or GPL license, right? So just like how open source licenses mean that the access to the code is free for anyone, just like that, Arduino releases its schematics publicly. That means anybody can buy the components and build an Arduino board. On top of that, the IDE that is used to program Arduino is also open source, and all of the libraries that are used to program it are also open source. So basically, it is a beginner-friendly hardware platform for you to learn how to build things with hardware. Like, whether it's something as simple as an electric doorbell to a smart home project, you can do that simple implementation in Arduino.
Talking about Arduino as an organization, as an open source organization. So when you started, how much beginner friendly was it then, and how much beginner friendly is it now, according to you, for a newbie?
Yeah. So I think that Arduino as a hardware platform and as a community is one of the most beginner friendly communities you can be a part of, because basically it's a platform. From a usability standpoint, all you need to know is very simple C or MicroPython. So C is one of the first languages we learn as we enter college, so that part is easy. Plus they have their own forum which they built after I finished GSoC. So the updated forum is now very beginner friendly. They have proper sections on where to ask questions if you are lost or if you have absolutely no idea. And I have personally asked a few questions on the forum and I've always gotten answers. So from that point of view, it's a very beginner friendly organization. And just there is this stigma around hardware that hardware is very complex and
Right.
kya hi karenge, but there is a perspective, right? One common internet thing, interview question that I've seen on LinkedIn is people ask, do you know what happens when you type something into Google search? So what if you took that question and reversed it? What happens when you compile a program and run it? Like basically, how does the computer execute a program? How do those electrical signals inside the board translate into things that happen? When you execute code, what does that actually mean at the transistor level? So learning about that, even if you don't intend on becoming a hardware developer, it gives you a very unique perspective about computers that's hard to find anywhere else.
So Ashutosh, one thing which I want to ask you here is that, as you said, that C is the requirement, right, for
Yeah,
contributing. So how
yeah,
much C is actually required for a beginner? Because some actually come to me and say that, okay, we know how to run loops, how to declare variables, a very basic stuff you say, right, in the
yeah,
C language. But
yeah,
some people don't have that much in-depth knowledge about pointers and stuff. So
yeah.
what can you shed some light on that part also?
Yeah, sure. So this is a very good question because again, estimating the depth is something that's very hard for a newbie, right? So What I'd say is like there are different aspects. Like, see, if you are contributing to the core library, or if you are contributing towards coding up something from scratch for backend support for a sensor, that may be complicated. You'll have to understand the concept of memory allocation and registers very well. But and this is a big but, because Arduino has a lot of sensors. Arduino is an entire platform, right? There are hundreds and thousands of sensors that are built for Arduino, and many of these sensors they don't have enough documentation. The libraries don't have any examples. Sometimes there are no repositories or places where people can ask questions. So if you want to contribute, say, sample programs, for that all you need to know is the Arduino subset of the C language, which is very small. It consists of basically if statements, loops, arrays, and then just assigning variables. So like say it's abstracted into, like, it's like exactly like software. Like in software, if you declare that a variable I is equal to 5, so in Arduino you can set a variable pin number 5 equal to high, and that will just set the voltage of that pin to 5. It's not like you need to do some complicated math or something. If you set 2 pins to high, connect an LED, the LED will light up. So I think the best way to get very comfortable with this is to just buy or get a cheap Arduino and 2-3 sensors, build 2 or 3 basic projects. There are always examples included in the IDE, and once you see 2-3 examples, right, you will understand it. After all, the platform is meant for school students and college students, right? So it's designed to be easy to use. So if you are designing examples, then one of the requirements that Arduino actually poses is that your example should be simple to understand. So from that point onwards, contributing to documentation or contributing to examples, sample programs and all that is very easy. You don't need to know a whole lot. In fact, I didn't even learn proper procedural programming in first year. I didn't know a whole lot about objects and classes, and still I'm not a Java guy like you, so I still don't know a lot about object-oriented programming, but I didn't find any trouble with Arduino, since most of the programs are also short, since you have limited memory to work with. So yeah.
So this is actually a great insight, because when we heard of a term hardware, so we get bit of overwhelmed. But okay, if you are saying that it is easier than object oriented programming, then we can actually believe you, because you are the one who is working, right? You said that newbies can contribute to the documentation part also, right? So
Yeah.
can we see like where they can contribute to?
Yeah, sure. I'll share my screen. So this is the Arduino forum, which is the place to ask questions. And again, over here we come here, right? So this is your Arduino's GitHub repository, right? So this links directly to the source. So let me show you something. Arduino's language reference. So this is, I think this ties into the previous question that that was asked as well. One sec. Yeah. So this basically, if you want to know about the Arduino language, right? So this is pretty much the whole language. Like read, there's read, write. There's some stuff, functions for trigonometry, like literally to calculate angles, math functions, random numbers, time, characters. Then obviously a variable like high, low, input, output, data types, variables, scopes. Then you have operators, bitwise operator comparison. So it's nothing that's not there in a first year basic C course, right? And obviously there is always like, if you want to contribute anything, so over here you can see that on the left they have a tab, find anything that can be improved, suggest corrections via GitHub. So you click on this and you come to Arduino reference documentation. So now you can see that they've given you entire reference that it's written in something known as ASCII doc format. This is not very complicated. basically if you know, like if you're familiar, like if you're familiar with the idea of markup languages like say Markdown or HTML, it's just like that. So they have told clearly how you can contribute the folder structure, the license, and then you can just click on that and you can see like whatever we were seeing there, right? Like here functions are there, so this is there for functions. So just like this for every Arduino library also, it directly links to the GitHub page from the Arduino website. So this makes it very easy to contribute documentation for Arduino, as well as the main org itself. They also have a lot of issues in the issues tab, and Arduino is really a community which requires contributors' help, because there are very few core developers in the company, in the Arduino company, and there is a lot to be done. So the issues tab is also has labels like good first issues and all that. So if you want to find something easy to contribute to, that is also a good place to ask. And in addition to that, obviously, if you are a total beginner and don't know where to start, then again, there are questions. This is the forum, right? So forum.arduino.cc. We'll be sharing all the links with you. There's a category on how to use Arduino. If you have built a personal project or you need help, Arduino is one of those orgs that even if you're building your own project, which has nothing to do with the open source community, you can still ask for help and they will help you. Then there's stuff related to hardware, the hardware family. So since Arduino has multiple boards, right? There's a nano size board, there's an IoT board, there's a Bluetooth board, then there is an MKR board. So all of these different boards have their own section. There's a section for software, for the community. So if you don't know where to ask questions, you can always go to community and ask a question in general discussion. Later on, when you graduate and get really good, then you can obviously join the developers mailing list where all of the work happens. But this is not for project troubleshooting and all that. This is for discussion regarding new features and all that. So yeah, that's a basic overview.
So apart from the forum, are there any dedicated chat channels also, like Gitter or something, or IRC or anything?
As far as I know, the GitHub what do you call it? The Google
Gitter.
group and the forum are the main things. They don't have a Gitter channel yet, although I think they are in the process of creating something like that. Because the main problem is the size. Arduino is a huge community, so anything that they create tends to become really big. Like actually, even in their forum, right? They migrated their forum and they had to migrate something like 500,000 viewers, like 5 lakh viewers to the new forum. So I think just because of the sheer number of messages that would be there, they don't have it. But the forum and the developers mailing list are good places to go to get started.
Yeah, and the forum is quite active, right?
Yeah, the forum is quite active. As you can see, even within the last few minutes, all of these messages that
Yes.
you see on the right side are within the last few minutes. So it's quite active. And their developers and even the people who work in the company, they're very active. Even my mentor for GSoC, his name was Alessandro Ranellucci. So he's one of the people who was involved in the creation of 3D printing, as in he literally created 3D printing software that all 3D printers use today. And he still took out time to mentor me and guide me. So it's a very friendly community. So recently, Arduino has come up with something really cool called the Cloud ID, right? So the main, why this was created was because initially people used to hesitate, we have to download an entire ID and then after that, make our stuff and then work with it, figure out which board we have to connect, which USB port and all that. Like there's the general thing about hardware, right? So they have created an IDE that runs inside the web browser, So basically, like if you have a cable and all that, if you have a USB cable and an Arduino and a couple of sensors and wires, you can get started. So here they have example sketches, right? So you can see the screen now. In examples, there are some built-in examples and from libraries. So basics start with very simple things. So there is one example called Blink, right? So I'm just going with something really basic here. Let's see the picture. So if you can see the screen, this is what an Arduino looks like. This is the board. So all of those little pins that you see are used for communication. They're known as general purpose input output pins. So this is nothing complicated. Basically, just like how you have a USB port on your computer or a HDMI port, right, for input output, you can use these pins to communicate with a computer, or you can use these pins to communicate with a sensor. So Arduino also comes with a built-in LED on the board. So I'm just rotating my mouse around that. On the middle of the back end of the board, there's one LED over here. So the first thing that every developer does, which is the equivalent of our hello world for hardware, is to blink that LED. Like, because you run a hello world program on a computer and you see the output, and every programmer's journey starts from there, right? So but in hardware, if you upload the program to the hardware, to the Arduino, nothing immediately happens. So how do you know if your program is working? Well, the answer is you blink an LED. So as you see, for blinking an LED, all we do is we write to the built-in LED, then we wait for 1000 milliseconds, and then we switch off the LED. So that's it. Everyone's journey starts from there. And once you move into libraries, right, then there's some really cool stuff that I can show you. I can show some of my own projects if you don't mind.
Yeah, sure.
Yeah, sure. So I can show you some of my own projects that involve Arduino, and some of them, when you combine Arduino with like say a Raspberry Pi and all, right, you can create some really cool stuff. So this was a project I built for a DevFolio hackathon, right? So this thing is can you see the screen? So
Yeah.
it looks like I know it looks like a like some kind of a weapon or a bomb, but basically this is a complete health monitoring system. The blue lines that you see on the screen, these take your ECG. The red line below that measures muscular activity. Then the screen over here, it measures your temperature, pulse, the atmospheric pressure, altitude, blood alcohol concentration, and all of these are the sensors which are used to measure that. These are the batteries that are powering it. The Arduino is under the board over here, and there's a Raspberry Pi under this board over here. So it's basically, if you learn, like say, some 3D printing and a little bit of electronics, right, it's like becoming a full stack engineer. You can think of an idea that, hey, can I create a hardware solution for this, and you can basically create it if there are sensors for it. So I find that aspect really cool. One more thing that my friend and I worked on with a bit of 3D printing knowledge was this is an entire prosthetic hand, like as in there's one servo over here, and there's an Arduino that's connected over here. And basically what we do is there are sensors for Arduino known as myoelectric sensors, as in it can measure the activity in your muscles by picking up the electrical signals in your muscles. So basically every time you flex a muscle or you tightly close your hand, electrical signals flow through your arm, right? So uh, this sensor can pick up that, and with some signal processing, we can make, for somebody who's lost their arm, we can make them have a mechanical arm that somewhat functions. It can at least open and close. Maybe you won't be able to write with it, we're not at that level yet, but at least you can open, close, hold things and all that. So these are some examples of stuff that I've done with Arduino. Yeah.
What advice do you want to give to the beginners so that they can start their contribution in the open source org itself? So
Uh,
a startup
yeah,
advice, like a starting advice, which you actually followed at your time.
yeah. So this advice includes some things that I did and some things that I should have done. So as with Arduino, with all other, as it goes for all orgs, the first thing is, do your homework. As in, like you're a beginner in open source, and obviously you're going to be very confused, right? So what I'd suggest is, like open source contributors all over, they always say that do your homework. What does this mean? That when you're asking a question, like say on the forum, you can't just say that help, my Arduino is not working, like, because the thing is it's hardware, right? So it's even like diagnosing software problems is always already complicated, but when it's hardware you have the added confusion of whether your sensor is not working or your board is not working or whether something's wrong with the software. So it's very important to be very exact in what you ask the forum. Like, you should say, I tried to flash the board, this is the error message I got, and then copy paste the error from the IDE into the thing, like, into the forum. So always do your homework. Like generally the thing is Arduino is used by a lot of beginners, so almost any question you have, just a simple Google search will solve it. 9 on 10 times that will solve your problem. And what I'd say is approach it with an open mind, because again, there's always a thought, right? But how will it benefit me? And obviously open source benefits all of us, even for me and even you, Kartik. It's benefited all of us career wise also. But the thing is, if you go in with that kind of a mentality, right, then it may not be immediately clear. I think there's a joy in contributing to open source for contributing to open source itself, just for that sake. So I'd say that first get the board, get an Arduino, because again, the thing is, if you're contributing to hardware, everything is theoretical unless and until the program correctly runs on the hardware, right? So get the board, get a USB cable, get a few wires and sensors. It's not very costly. You can get Chinese clones of Arduino for like 300, 200 bucks. And since it's open source, all of them are perfectly legal to use. Nobody will tell you off for that. Get the hardware, try a few things, get familiar with the product first. It's not always necessary to understand the product at an intimate level before contributing, but Arduino is one of those organizations, or in general hardware projects, you have to really get familiar with the hardware and the idea of debugging the hardware, like buying a multimeter and measuring voltages to see if something is fused, or seeing the output on the terminal monitor whether it's working or not. So get the hardware, get familiar with it, and then only take the next step of contributing. Your pull requests will have some back and forth because they have coding guidelines, right? Arduino has a fairly lengthy contributing.md document. So, this is always a good document to read for any open source repository. Please read this document first, because it has rules, types of contribution, how to contribute, how to report bugs, how to report issues. If you want to translate something, if you want to, like, let's say, Hindi or Bengali or something, and you want to provide a version of the Arduino language reference for that, you can even do that. Donating, and issues, where to report which issues. So built-in examples have a separate thing, this thing. So if you read these documents, and then even on pull requests, right, they have a thing that if you have very big changes to the API and all that, which you probably won't do in the beginning, how to contribute. You should also go through a few pull requests by other people. This is very important, so that you can see the general flow of things. Because you might get intimidated that why am I getting asked so many questions if you are new, but that is a normal thing. Nobody is attacking you or being aggressive. That's just how it works. People ask for justification. Why are we doing it this way? Why not this way? So even how to give commit messages and all that, they have development policy and all that. So just start with the GitHub site and read all these documents. It will take some time, but it will save you a lot of confusion later. So yeah, that's it, I think.
So if to summarize, we can say that first thing is try to search things properly. So you should be good at
Yeah.
Google search, and it is actually pretty much common with every open source organization there. So you
Yeah.
cannot ask like, okay, how to set up a software project without even going through the documentation and doing some workarounds, right?
Yeah.
So same
Yeah.
thing is here also, because here with the software, hardware also gets involved. So
Yeah.
yes, you have to do that stuff, and all the links will be in the description as well, so you should go through the links, read them properly, because here Ashutosh and I cannot just explain and read everything for you. Some things you have to do, right?
Yeah.
And be good at asking questions, because soft skills are good and are actually required in everything. And try to ping on the personal channel or the personal forum as possible, and after having a thorough Google search. So I think that just pretty much wraps up the discussion about Arduino, and I want to thank Ashutosh for being here. So thank you very much. And
Yeah.
so
Yeah.
that's all, guys, and I hope that you actually liked it very well. So like it and share it also. So that's it for this podcast, and we'll be meeting you in the next episode of this Open Source Org Awareness podcast. So thank you very much, guys.